Imagine dropping a fragile glass vase onto a hard concrete floor. You brace yourself with the sound of shattered glass, but instead, you hear nothing more than a soft series of tiny pops. Those little air-filled bubbles just save something worth hundreds of dollars. But here's what nobody tells you. Every single bubble has to be formed with incredible precision. If even one part of the process goes wrong, millions of sheets become worthless in minutes. Today, you're about to step inside the hidden factories where one of the world's most recognizable packaging materials comes to life. Most people see bubble wrap as a simple sheet of plastic covered with tiny air pockets. In reality, it's a result of high-speed engineering, advanced polymer science, and manufacturing lines that stretch longer than a football field. Massive machines melt plastic, trap perfectly measured volumes of air, and seal thousands of bubbles every single second. Think about this. The bubbles protecting your latest online purchase began their journey hundreds or even thousands of kilometers away, long before they ever reached the factory. And this is where it gets truly extraordinary. The air trapped inside each bubble doesn't simply happen by accident. Engineers carefully control heat, pressure, speed, and timing so every pocket seals perfectly before the plastic cools. A delay of just a fraction of a second can ruin an entire production run worth thousands of dollars. What happens next surprised even experienced engineers when modern automation pushed the limits of speed beyond what human eyes can easily follow. Everything begins deep beneath the earth. The main ingredient in bubble wrap isn't harvested from forests or farms. It starts as crude oil and natural gas extracted from enormous energy fields around the world. Some of the largest supplies come from the United States, Saudi Arabia, Canada, Qatar, and the United Arab Emirates. These underground reservoirs formed over millions of years, storing ancient organic material that eventually transformed into hydrocarbons. It's incredible to think that something protecting your package today may have started its journey beneath a desert or beneath the ocean floor. After extraction, the crude oil travels through pipelines, rail cars, and giant ocean tankers to some of the world's largest refineries. Inside these facilities, towering distillation columns heat the crude to around 350 to 400 degrees Celsius, or roughly 662 to 752 degrees Fahrenheit. Different hydrocarbons separate into valuable products, including naphtha, the essential building block for many plastics. Flames roar beneath enormous steel towers, while miles of shiny pipes carry superheated liquids in every direction. Next comes one of the most important chemical transformations in the entire journey. Refineries send naphtha into massive steam crackers operating close to 850 degrees Celsius, or about 1,562 degrees Fahrenheit. In only fractions of a second, intense heat breaks large hydrocarbon molecules apart, creating ethylene gas. You can't see the reaction with your eyes, but this invisible process produces the tiny molecules that eventually become nearly every sheet of bubble wrap on Earth. Chemical plants then transform ethylene into low-density polyethylene, better known as LDP. Under pressures exceeding 2,000 bar or nearly 29,000 psi, specialized reactors join countless ethylene molecules together into long polymer chains. The result cools into tiny translucent pellets about the size of rice grains. Each pellet may look insignificant, but millions of them will soon become thousands of square meters of protective packaging. Before these pellets ever reach a bubble wrap factory, technicians inspect them for purity, color consistency, and moisture content. Premium manufacturers often demand polymer purity above 99.9% because even tiny contaminants can weaken the finished film. Sophisticated dryers remove microscopic traces of water before the pellets travel in giant hopper trucks or rail cars. Most people never think about this, but a single truckload can carry more than 25 metric tons of material, enough to manufacture kilometers of bubble wrap. The journey doesn't end with plastic alone. Manufacturers also blend antioxidants, processing stabilizers, anti-block agents, and slip additives into carefully measured recipes. These microscopic ingredients help the film glide smoothly through high-speed rollers, resist heat during manufacturing, and remain flexible during shipping. Without them, sheets could stick together, tear too easily, or lose their crystal-clear appearance after only a short time in storage. Of course, producing plastics comes with environmental challenges. Modern manufacturers increasingly incorporate recycled polyethylene into selected products while improving energy efficiency and reducing production waste. Scrap film often returns directly into the manufacturing process instead of being discarded. Every improvement saves raw material, reduces emissions, and lowers costs, but the greatest engineering challenge still lies ahead. Because turning these tiny pellets into millions of perfectly sealed bubbles requires a manufacturing process so fast that it almost looks like magic. The moment the plastic pellets arrive at production line, the factory suddenly comes alive. Powerful vacuum loaders pull thousands of pellets every minute into towering storage hoppers positioned above the extrusion machine. You hear a constant rush that sounds like a powerful windstorm as the pellets race through stainless steel pipes. But here's what nobody tells you. The real transformation begins the instant those tiny pellets meet intense heat. Inside the extruder, a massive steel screw measuring more than 2 meters long rotates between 60 and 120 revolutions per minute, steadily pushing the pellets forward. Electric heaters divide the barrel into multiple temperature zones, gradually raising the plastic from room temperature to between 180 and 230 degrees Celsius, or 356 to 446 degrees Fahrenheit. Friction between the rotating screw and the melting polymer creates additional heat until the pellets disappear into a crystal-clear liquid. The smell resembles warm plastic, while the machine vibrates with incredible force as several hundred kilograms of material flow through every hour. Before the molten plastic can become bubble wrap, it must pass through an ultrafine screen pack that filters out even microscopic contaminants. The melt reaches pressures between 150 and 300 bar, or roughly 2,175 to 4,350 psi, while hydraulic systems force it through stainless steel mesh finer than a human hair. If a tiny metal particle slips through, it could puncture thousands of bubbles downstream. That's why operators constantly monitor pressure gauges, because even a slight change can signal trouble long before anyone sees it. Now comes a moment that gives bubble wrap its famous shape. The extrusion die spreads a molten plastic into a perfectly uniform sheet, only fractions of a millimeter thick. A second film follows close behind, while a precision-engineered forming roller covered with thousands of tiny cavities rotates underneath. Every cavity waits to become a bubble, but something invisible makes the magic happen. Powerful vacuum pumps pull air from beneath the hot plastic, forcing the soft film deep into every tiny cavity of the forming roller. Each bubble begins to take shape in less than a second. At the same time, carefully regulated compressed air replaces a vacuum, ensuring every pocket contains nearly identical air volume. What happens next surprised even experienced engineers. The bubbles don't simply inflate. They lock into place with astonishing precision while moving faster than a person can run. A second molten film immediately meets the bubble layer, while heated laminating rollers press the two sheets together. The rollers maintain temperatures around 110 to 140 degrees Celsius, or 230 to 284 degrees Fahrenheit, applying carefully controlled pressure to create an airtight seal around every single bubble. Miss the timing by even a fraction of a second, and trapped air escapes before sealing. Imagine millions of bubbles collapsing at once. That's exactly what operators work tirelessly to prevent. Freshly sealed bubble wrap now enters a series of chilled cooling rollers, circulating water at approximately 10 to 20 degrees Celsius, or 50 to 68 degrees Fahrenheit. Within seconds, the soft plastic hardens while preserving every bubble's shape. The film glides smoothly across polished rollers at speeds reaching 40 to 120 meters per minute, producing a mesmerizing wave of perfectly aligned bubbles stretching across the factory floor. Next, automated edge trimmers remove uneven borders with razor-sharp rotary blades spinning thousands of revolutions per minute. Powerful vacuum systems immediately collect every scrap and send it back for recycling. Nothing goes to waste if it meets quality standards. The constant hum of motors mixes with the crisp slicing sound precision cutters as every sheet becomes perfectly square. The finished material finally reaches enormous winding machines that roll the bubble wrap under carefully controlled tension. Laser sensors continuously measure roll diameter, while servo motors adjust speed automatically, preventing wrinkles or crushed bubbles. Some industrial lines produce more than 1,500 square meters of bubble wrap every hour, enough to wrap thousands of fragile products before the next shift even begins. But here's the mystery. How do manufacturers know every single bubble will survive the rough journey from factory to customer? Before a single roll leaves a factory, an invisible army of sensors begins its inspection. High-speed AI vision systems capture thousands of images every second, searching for bubbles that look even slightly different from the rest. Imagine trying to inspect millions of tiny air pockets with your own eyes. It would be impossible. But these cameras never blink, never get tired, and never miss the smallest detail. Laser measurement systems immediately verify the height and spacing of every bubble. Most manufacturers allow dimensional tolerances of only about plus or minus 0.2 millimeters, because even tiny variations reduce cushioning performance. As the sheet races past at over 100 meters per minute, precision lasers create a three-dimensional map of the surface. What happens next surprised even experienced engineers. The computer can reject defective material before a human operator even notices a problem. Pressure sensors monitor every stage of production, from the molten polymer inside the extruder to the air sealed inside each bubble. If extrusion pressure changes by only a few bar, the entire production line automatically adjusts screw speed, airflow, and roller pressure in seconds. You hear motors speed up and slow down almost instantly as the factory constantly fine-tunes itself. Modern automation makes thousands of tiny corrections every hour without stopping production. Now the bubble wrap faces its first real challenge. Automated compression machines repeatedly squeeze the bubbles under carefully measured loads to simulate shipping conditions. Some test apply forces of several hundred newtons thousands of times in a single cycle, measuring exactly how much cushioning remains after repeated impacts. The familiar popping sound you love actually signals failure inside the laboratory, because quality engineers expect those bubbles to survive, not burst. Another machine performs tensile strength tests by gripping both ends of the film and pulling until it stretches to its limit. Sophisticated load cells record the exact force required before the plastic tears. At the same time, puncture resistance machines press hardened steel probes into individual bubbles to measure how much protection they can provide against sharp objects. Every test answers one simple question. Will this packaging protect someone's valuable purchase? Climate chambers push the material even further. Engineers expose bubble wrap to freezing temperatures near minus 30 degrees Celsius or minus 22 degrees Fahrenheit, and then to scorching heat approaching 70 degrees Celsius or 158 degrees Fahrenheit. High humidity tests run for hours or even days to ensure the plastic remains flexible in warehouses, cargo ships, and delivery trucks around the world. Most people never think about this, but a package might travel across deserts, mountains, and oceans before it reaches your doorstep. Factories also verify compliance with internationally recognized quality management systems, such as ISO 9001, while many products undergo additional packaging performance tests based on customer requirements and shipping standards. Random samples leave the production line every hour for inspection, and well-controlled manufacturing lines typically keep rejection rates below 1%. Every accepted roll carries production codes that allow engineers to trace it back to the exact machine, operator, raw material batch, and production time within minutes. Yet even inside one of the world's most automated factories, human experience still makes the difference. Veteran technicians can hear a slight change in the sound of an extrusion line, or notice a barely visible ripple long before software raises an alarm. Years of experience allow them to solve problems that machines haven't learned to recognize. And this is where it gets truly extraordinary, because the journey of bubble wrap doesn't end inside the factory. It continues across the entire planet in numbers so enormous they're almost impossible to imagine. Now step back and imagine scale. The global packaging industry produces billions of square meters of bubble wrap and similar air cushion packaging every year. Enough to wrap countless shipments moving through warehouses, trucks, ships, and aircraft every single day. The protective packaging market is worth tens of billions of US dollars annually, driven by booming e-commerce, electronics, medical equipment, and industrial logistics. Think about this. Every time you click buy now, there's a good chance a sheet of bubble wrap begins another journey somewhere in the world. What seems like an ordinary piece of plastic has become one of the invisible foundations of global trade. Today, China leads global production with approximately 35% of the world's manufacturing capacity, followed by the United States at around 18%, India with roughly 8%, Germany near 6%, and Japan close to 5%. Together, these countries supply protective packaging to nearly every major economy on Earth. Thousands of factories operate day and night, while millions of workers across petrochemicals, plastics processing, transportation, machinery, and logistics help keep the supply chain moving. It's a worldwide effort that most people never see. The story of bubble wrap began with an accident. In 1957, inventors Alfred Fielding and Mark Chavon experimented by sealing two plastic shower curtains together, hoping to create a textured wallpaper. The wallpaper failed completely, but the trapped air sparked a much bigger idea. A few years later, companies recognized an incredible ability to protect fragile products during shipping, and an entirely new industry was born. Sometimes the world's greatest inventions arrive when the original plan goes completely wrong. Over the last 50 years, manufacturers have transformed bubble wrap beyond recognition. Early production relied heavily on mechanical controls and manual adjustments, while today's factories use AI vision systems, servo motors, robotic handling, predictive maintenance software, and real-time data analysis. Production speeds have multiplied, waste has dropped dramatically, and quality has reached levels engineers once thought impossible. What once protected a few household items now safeguards everything from smartphones and artwork to satellites and life-saving medical equipment. And the future looks even more remarkable. Researchers continue developing thinner films that deliver the same protection while using less plastic. Manufacturers are expanding recycled content, exploring bio-based polymers, and integrating smart factory systems that predict maintenance before machines fail. Advanced air cushion packaging produced on demand may reduce transportation costs and storage space even further. The next generation of protective packaging won't just protect products, it will help protect resources as well. Here's something that might surprise you. Did you know bubble wrap was never originally designed for packaging? Did you know the air trapped inside millions of bubbles often weighs less than the product it protects? And did you know modern manufacturing lines can create enough bubble wrap during a single workday to stretch for many kilometers if laid end to end? Those tiny popping bubbles hide a level of engineering that few people ever imagine. You began this journey with a simple question about a sheet of plastic filled with air. Along the way, you've traveled from ancient oil and natural gas deposits buried beneath the earth to massive refineries, precision chemical plants, high-speed extrusion lines, intelligent robots, and laboratories where every bubble earns its place. Every role represents the work of scientists, engineers, technicians, machine operators, logistics experts, and countless others working together across continents. The next time you hear that satisfying pop, you'll know you're holding far more than packaging. You're holding decades of innovation, precision engineering, and one of the hidden success stories of modern manufacturing. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.